Hello, everyone. Welcome to today's webinar. This is Terry Ersman. I'm the Chief Marketing Officer for Percona, and it gives me great pleasure to introduce Baron Schwartz, our Chief Performance Architect, who will speak about verifying MySQL replication integrity. Baron?
Thanks, Terry. Do you hear me okay?
I do.
Great, thanks. I'll just go ahead and get started then. Welcome, everyone. Thanks for joining us today. Just a brief overview of what we'll cover today. I'll just introduce myself briefly, and then I want to talk a little bit about the motivation for today's presentation and why I wrote the tools that I did to help us achieve the goals that I'll be talking about in a minute. And we've released a new version of the software in the last few weeks, and I'll introduce what's new there. And at the end, I'll wrap up with some resources for further learning and take questions at the end. If you'd like, feel free to ask questions at any point throughout. I'm happy to pause and interrupt and explain something sort of when it's in context rather than having to page back through the slides and find out where I was. So Terry can ping me about any questions that you ask. So this is me. That's my glamour shot. And on the right side is a book that I wrote, the second edition of High Performance MySQL. I wrote that together with Peter and Vadim, who are the co-founders of Percona. And we're nearly complete with writing a third edition, going through proofs and responding to copy editor comments right now. And that should be out in a couple of months. You can pre-order it on Amazon right now, and I'll have a link to that at the end in the resources section. Third edition I thought was just going to be a refresh of the second edition, which was a complete rewrite of the book. But I turned out to be, I think, a more efficient writer in the third edition, and I ended up having more time than I thought I would to make changes to the book. So the third edition is a really big upgrade over the second edition. I'm very, very pleased with it, and I hope that it turns out to be as popular as the second edition has been, and as useful to folks as people have told me it is. And this is Percona, of course, my employer, and we provide software and services in general for MySQL users. We try and help people get the most out of MySQL. We make MySQL faster and more reliable for them, but we also help them to achieve their business goals. So it's a mixture of consulting and support and providing enhanced versions of software. And in some cases, like we'll discuss today, software that's completely unique within the MySQL ecosystem, software that has no substitute. And that's primarily Percona Toolkit, which is something that I started as an open source project back in 2006. At that time it was called MySQL Toolkit. I renamed it to MottKit to avoid some trademark concerns. And over the last 6 months or so, we've bundled that together with another toolkit that I started called Asperza. And we've wrapped those into one and called it the Percona Toolkit. And we've got dedicated in-house staff working on that. This is the essential administrator's toolkit for MySQL. I think it's pretty well acknowledged that some of the things you can do with MottKit, some things are very difficult to do otherwise, and some things are practically impossible. It's very helpful to our customers as well as to us when we're consulting and helping in support cases and the like. So with that as a background, let me talk about why replication can bite you and why you should care about that and what you can do about it. So the first thing is that replication is fallible. Replication in MySQL is asynchronous, which means that when transactions commit on the master, there are very few and loose guarantees about what happens to them. The replicas will fetch those transactions and replay them sometime later to bring their copy of data up to date with the master, and in general that's very fast, sub-millisecond in most cases. But long-running transactions can cause things to get delayed, and replication, in fact, can completely fail and break. And you'll see when this happens, the typical thing is that you'll see an error in the output of show slave status that will say something like duplicate key violation, or there's a variety of other failure modes that can happen. But so replication can absolutely just stop working completely. And replication, as I just mentioned a second ago, can also just get delayed, can fall behind the master. This can happen if the master is overloading the replica with too much traffic, or for a variety of other reasons. It can be poorly optimized SQL or bad indexing or the like. And what happens then is that the application reads stale data. Now, today I'm not going to be talking specifically about how to address this. That's worth another whole talk, but I'm just going to distinguish between the two of these in a moment. And finally, the third thing that can happen, which is pretty much invisible, this is kind of like the radioactive gas leaking into your basement. You don't really know about it, but it's there and it can burn you anyway. And that is that the data on the replicas can actually diverge logically from the master. So at any instant in time, your replica might have a set of data that never existed at any other point in time on the master. And this can be silent. Your replica can keep humming along quite nicely for a while if there are no, for example, primary key conflicts or anything like that. So you might never know about it. And in fact, I would say in the majority of cases that I've seen, people don't know about it because if there is a failure that blocks things, people tend to resolve that. But it's those silent failures that get people. And why you should be worried about this is because of things like taking backups from your replica, or for the same reason that I mentioned in the second point on the middle of this slide here. If your application is reading from a replica as well as writing on the master, for example, or reading from multiple replicas, you can get inconsistent data because the replica doesn't have the same data that the master does. So in summary, if you use replication, then these silent failures can happen, and you really need to guard against it. And there's no built-in way to do that. People generally don't talk a whole lot about this. Back in 2006, this was the first tool that I wrote in what today is Percona Toolkit, because I realized that there were some problems in our replica set. At that time, I was not a consultant. I was actually a database administrator for a company. And I realized that there were some data differences that were not causing replication to fail, and that MySQL didn't have any built-in way to safeguard against that or to warn when it happened, which meant that I had to find some kind of a creative way to do that. And it turned out to be a long process and a lot of conversations with other people at the MySQL conference, much brainstorming, and eventually we collectively found a way to detect that. And that's what I'm going to be talking about today. So here's the gist of how it works. You've got your master and your replica, and you have some tables on the master. Now, on your replica, if you notice towards the bottom of that little icon indicating the table, one of those little lines representing a row of data in that table is shorter, and it's red. And that represents that that row is different than it is on the master for whatever reason. Now, there's lots and lots of reasons that this can happen. There are certain statements that you can execute that are actually not safe for statement-based replication, for example, and they'll produce different results when they replay on the replica than they did on the master originally. Or perhaps somebody connected to the replica and made some changes there instead of making changes as they should have only on the master. There's a whole variety of different ways that this can happen. And in fact, in high performance MySQL, I've got a whole section. I forget how many pages it is. It might be 6 or 8 or 10 pages on all of the different ways that things can go wrong. Or it's actually not all, but it's a list of the most common ways that things can go wrong in replication and cause this data to drift out of sync. So the way that we detect that is that we create a small table, and we take groups of rows in each of those tables, and we do a checksum query from them. It's a pretty complicated little query, and it has some magic in it. But it ends up resulting in a checksum of those rows within that group. And we insert that into another table. So on the upper left, we've done 2 insert select and dropped a little row of data for each of those chunks of data into the little table on the right-hand side. Now, the resulting checksums are very compact, much more compact than the data itself. These checksums typically group thousands or tens of thousands of rows together, and you get a single value out of it. So it's very analogous to checksumming that you might be used to on files for MD5, for example. And in fact, internally, it does use MD5 sum or CRC32 or other. You can use cryptographic checksums like SHA-1. those kinds of things inside of MySQL. Those are built-in functions. And in the Percona server distribution, we actually ship some much, much faster 64-bit checksums that you can also take advantage of. Those can be plugged into the MySQL server to make this process even faster. So that happens on the master, and then it flows through replication. And down here on the replica, the resulting checksum is represented in red. And that's because it's different than it is on the master. So if you looked at the checksum rows on the master and on the replica, you would find that they're actually different. And that's how we can detect that the replica's data has diverged away from the masters, because this insert select will actually produce different results on the replica than it does on the master, because the replica has different data than the master does. And finally, we then go back to the table on the master. We read those checksums out and we insert them back in, just filling in another column in that row. And those replicate through. But they replicate consistently because those are literal values that get passed down through replication. And now on the replica, we can actually look at that single row in the checksum table that I've highlighted with a red oval here, and we can see that this replica's checksum of that chunk of rows in that table is different from the master's checksum of the same rows. And that makes it very easy and convenient for us to figure out which chunks of rows in which tables are different from the master. So now we take this conceptually simple approach and we wrap a tool around it with a lot of pretty smart intelligence and lots and lots of advanced techniques. And we do this on the whole server instead of just one table. So that's what pt-table-checksum does. Now I want to come back to a topic that I touched on briefly before, and that's that there's a difference between logical data differences and data that's just different because it represents a different logical point in time. This technique that I've just shown you is immune to false positives due to the replica being delayed relative to the master. These checksums are consistent at an instantaneous point in time as of when the transaction committed on the master. Now that transaction might not complete until sometime later on the replica, but that's okay, because when you do go look at the data, you will see a consistent view. And if the replica says that its data is different from the master's, then you can rest assured that it really is different. So there's a big difference here between a replica being delayed and a replica actually having a different set of data than the master. There are other tools in Percona Toolkit that can help you to determine whether your replication is delayed or not. Of course, you can look at show slave status, and there is a column called seconds behind master, but that turns out not to be a reliable indicator. It has a number of failure modes. So there's another tool in Percona Toolkit called pt-heartbeat that can help you do that in a reliable way. So the tool that does replication integrity detection in Percona Toolkit is called pt-table-checksum. And it pretty much does what it sounds like. It checksums all of the tables in a database. So how you use it is you download it, install it, and execute it. And that's pretty much it. You don't have to do a lot of configuration. There's not a lot of complexity to how you use it. There's a lot of complexity to how the tool works internally, but we built that tool in so that you, the user, don't have to deal with complexity. Making things simple for the user means that the tool has to do the heavy lifting for you. And I've got a screenshot in a moment here of how to use this. So I have given a command line argument here. I've just executed pt-table-checksum. I didn't even install it. All I did was make it executable. These tools are generally standalone. They don't have to be installed into any specific place in the system. They don't have many external dependencies. They're written in Perl, so they have a couple of core dependencies on some of the built-in Perl modules. But in general, there's not a lot of work that you have to do to get these tools installed and running. And we make sure that that's the case in part because we use these tools as consultants where we have to kind of parachute into a system very quickly and get going with it. And we don't have any ability or privileges to install things on the system or modify the system in any way. So that's why you end up with a very easy user experience if you choose to just download the tool and execute it. You don't really have to install it. So I've just executed it here against a little sample database that's shipped with MySQL. You can download this from dev.mysql.com. the Sequila sample database, and I've specified one command line argument, which is --databases Sequila. And I did that just to keep the output brief enough that it wouldn't scroll and make this too hard to look at. I'll show that magnified to you in a moment. But here's what the tool does. It connects to a server, and it behaves just like MySQL by default, meaning the noodles try and connect to localhost if you don't tell it where else to connect. And then it discovers and connects to all of the replicas that are attached to that server. So what you typically want to do is run this on your master, and then it will automatically detect all of your replicas and connect to them. And the reason that it detects and connects to your replicas is so that it can do some safety checks. Because replication is brittle, as I mentioned earlier, and there are a wide variety of failure modes, we try and detect most of those in the tool and prevent them or avoid them, or at least make the tool bail out and give you a warning message about why it refuses to operate and what you can do. If you think that the tool can operate safely, you can override those. So it runs a variety of safety checks. I can't quite remember off the top of my head how many safety checks there are. There are probably over a dozen, and they're pretty extensive, and a lot of those things are pretty subtle. And I'll go into those a little bit more in a moment. And then it starts discovering databases and tables. And as it discovers each database and each table and inspects the schema of the table, and then runs checksums by paginating through the table, paginating through in chunks of rows at a time. And I'll explain that a little bit more in a moment as well. This process is very efficient and lightweight. It does not do silly paginate with expensive offset statements, for example. Years and years of different pagination techniques have been tried, and many of them have been discarded. And this tool represents the best that we can do. And in fact, it's extremely lightweight on the server. And finally, it reports the results, and it does that all in one. I'll come back to that sample output in a moment and kind of give you a little guided tour of that. So here's the sample output, and it's in columns. On the left-hand side, we have a timestamp, and that's abbreviated just to keep things as compact as we can. In case you're looking at this on a terminal, for example, we don't want to take up a whole lot of space. So I actually ran this a little bit earlier today at 11 o'clock this morning. That's the first column, the timestamp column. And then we have a column that shows whether there were any errors, any differences were detected, how many rows were in the table, and each of these lines of output represents a table, by the way. The number of chunks that we divided that table into as we checksummed our way through it, how many of those chunks we might have skipped for one reason or another, the total time it took to checksum that table, and then the table name. So there's a lot of information there. And typically you should see errors 0 all the way down. You should see diffs 0 all the way down unless any chunks of rows actually have different data from the master. And in that case, diffs will show you how many of those chunks of rows differ on at least one replica. And the rows are reported from the master, and the number of chunks are also reported from the master. I'll come back in a little bit to why you might the tool might choose to skip some chunks of rows. But first, let me explain kind of what's new in this new release that we. I believe this was over Christmas. No, I'm sorry. It was just after the new year. I'm confusing releases. We released version 2.0 just after the new year, and the major upgrade that is present in Percona Toolkit version 2.0 is, in fact, pt-table-checksum. So if you're familiar with pt-table-checksum version 1.0 or using mk-table-checksum from ModKit, which is the ancestor to this project, forget everything that you knew about how it was complicated to run and complicated to administer, and it was brittle and had to be restarted a lot. This tool is really, really simple and resilient and just does the right thing by default. It adjusts itself as it goes through, and it avoids causing impact onto the system. And in fact, it's very hard to make this tool quit. You can intentionally make it quit, but it handles almost every kind of an error that might be thrown at it. And it does that in a pretty graceful way. So I'll go through each of these bullet points. It only does one thing. Version 1.0 of this tool used to do a whole bunch of different things. You could run it in lots and lots of different modes. And we've removed all of that because what we ended up using this tool for, and I would say upwards of 95 or 98% of cases, was exactly this one use case, determining whether replication has drifted relative to the master. So this tool only does that now. And we've combined and eliminated a lot of the steps that you used to have to do to get that functionality in the old version of the tool. For example, you used to have to run it in checksum mode, and then you had to run it again to detect whether there were any data differences. No more. Those are now in one smooth step. All of those behaviors are combined into one operation. So you just run the tool once, and it does everything that you need. We removed a lot of the command line options. In particular, there were a lot of complex things that we made self-tuning, and I'll talk about that in a moment. So a lot of those command line options just went away. And we also removed a lot of the complexity about how we determine ranges of rows to chunks so that we're doing this in small nibbles to avoid intruding on the server. So there's now only one technique, and it just works and just does the right thing, and that removed a great deal of complexity too. So right there, we just removed a whole bunch of things that you used to have to think about and tune and tweak and configure and try again, and all of that it's just gone. It just works now. I mentioned that the tool is self-tuning, and in particular, one of our goals here is to make the tool have sensible command line options so that it does the right thing by default. And this is a practice and an approach that we're applying to more and more tools. I'm going to mention at the end some of the other tools that we're currently working on upgrading now. My goal is that every tool should do something useful by default if you just run it. And most of these things self-adjust. So they detect what kind of an environment they're being run in. They detect how much load is on the server, and it just does the right thing. So you can actually run this tool with no options. Let me page back here a couple and show you. I ran it only here with the database's Sequila option to filter out which tables get checksums, but otherwise I ran it with no options. And if you just run it with no options, it does the right thing. It does what you expect. So another really important feature is to make this tool very safe for your servers. Checksumming this data is a reasonable amount of work, and that's really not a problem if you spread it out over a long period of time. If you put too much work on the server at once, you can have the sort of obvious effects. You can slow down other queries that are on the server that you don't want to slow down. You can overload the replicas and make them get delayed. That was a common complaint in version 1.0 of the tool. And we used to have a lot of options like sleep time and all of these kinds of things that would make the tool sleep in between chunks. And what we've done now is we've taken a different approach. Each chunk of rows has a target time. And I believe that's on my next slide, actually. Well, maybe the next one. All right, I'll just leave those up on the screen and talk through it. Each chunk of rows has a target time, and it self-adjusts. So if the server starts to come under heavier load, it'll actually start checksumming fewer and fewer rows in each chunk so that it can do them in the target amount of time, which is 1/2 a second by default. And in practice, it uses a pretty snazzy algorithm to detect when things change on the server. For example, if you start to enter your peak time, it'll start to throttle itself back more and more and more. And this works extremely well in practice. I've run it on a lot of changing workloads and analyzed the results, and it does achieve the desired result. It will also configure itself to be the victim as much as possible in case there is any blocking. For example, these insert select checksum statements will actually take some locks on the rows that they're selecting from. And we don't want that to cause anything like InnoDB lock wait timeouts or deadlocks or anything like that. So what we try and do is make the tool turn itself into the victim so that your application continues to run. And this tool is configured to just deal with that kind of interruption. It should be the polite tool that yields to everything else on the system. And because it has detected and connected to all of your replicas, it watches those replicas and looks for signs of them starting to get into trouble, such as increasing replication delay. And it will wait if they start to delay, or if anything else happens, such as they fail. So if the replication stops on any of the replicas, the tool will pause. If there are replication filters, those are dangerous because it's potentially the case that you've got some some fancy replication filtering set up that the tool can't really deal with. There's no single way to deal with this correctly that the tool could automatically and reliably detect. So it'll actually refuse to run if there are filters on replication, and the user has to figure out what to do about that. There are, again, dozens and dozens of safety and sanity checks that it does. One of them that I'd mention is that if a table is empty on the master, it doesn't just assume that that means it's going to be inexpensive to checksum this table. In fact, it'll connect to the replicas and look and see if the table is empty on the replicas. If it's too large on the replica to checksum safely, it'll just skip it. That way we don't get what looks like a really cheap operation on the master, causing the replicas to accrue a lot of delay and fall really far behind. And I don't have time to go into all of the safety and sanity checks, but they are listed in the documentation. If you read the documentation, it's a pretty good little manual there about what the tool does to protect you. So the tool, making itself sort of the polite tool that yields to everything else on the system, suddenly becomes extremely important for this tool to deal with all kinds of failure scenarios, like lock wait timeouts, like disconnections, like the servers shutting down and restarting. And this might not sound like such a big deal, but my experience in running this in production on very large systems, and we have run this in production on systems with many, many billions, hundreds of billions of rows. My experience is that if the tool doesn't cope well with failure scenarios and has to be restarted or has any other sort of special needs, then it ends up causing you not to get your job done, because you'll go home at 5 o'clock and the tool will fail at 5:30, and you'll come in the next morning and realize that you lost the entire night's worth of checksumming opportunity because the tool had failed. So it will, you can pretty much kick this tool in the teeth, and it will get back up and politely wait until the coast is clear, and then it will continue. And when I say kick it in the teeth, I mean that you can actually run one of Percona Toolkit's other tools against the system called pt-kill, which kills long-running queries. I've tested this to just kill this tool's queries whether they're long-running or not, and kill them as fast as possible. And what do you know? It just continues to recuperate and restart itself and reconnect when it gets disconnected. And it's pretty hard for any kind of an error condition to make this tool fail. Now, you can Control-C it or send it a kill signal or something like that if you want to, and it will immediately stop what it's doing then. But otherwise, it copes with all of the sort of inevitable failures and problems that crop up during a long, intensive operation. I mentioned that it checksums in chunks. It starts out by looking for a chunk of 1,000 rows, and thereafter it tries to target a half a second, as I mentioned. And this works on any table that has an index. If there's not an index on the table, it will just skip it. That's actually not true. If the table is small enough that it can be done in a single chunk, it will do it in a single chunk. But if you have a large table that needs to be divided up into chunks so that it can achieve that target time of a half a second or whatever you configure there, then it will not run a checksum query that it thinks is going to exceed that target time. And we paginate through that table very smartly. What we do is, let's suppose that we want to select 1,000 rows and checksum them. We actually select 1,001 rows, and we use that 1,001st row to detect a few different kinds of error conditions that might happen, such as getting into an infinite loop sort of a situation. We also use that 1,001st row as the bookmark for where we should start the next chunk. And so it goes. We checksum 1,001, we start where we left off, and we go through the whole table. It's very lightweight, very efficient. It uses hardly any resources at all in the tool. All of the resources that it uses are in the MySQL server, and it's, again, not intrusive there. Here are a few of the command line options. There are lots and lots of command line options. Most of them you'll never need to think about. But here are a few of the ones that you might care about. The chunk time is that target time for how long it should take each checksum query to complete. And that is a half second by default, as I mentioned. Sometimes I like to set that down to 1/10 of a second or even less, depending on how sensitive I believe the server is. But half a second generally tends to work out just fine. The replicate option specifies the little checksum table that we're going to put those checksums in. This is called replicate for legacy reasons, to make sure that it's backwards compatible with version 1.0 of the tool. This has a default. It's Percona.checksums. If you don't do anything else, the tool will actually create that table for you, and it will give it the correct structure. If you want to put it somewhere else, if you want to put it in a specific database, for example, then you can use the replicate option to specify where that checksum table is that should be recording the little checksums. Resume is extremely important if you do decide to kill the tool for any reason. You don't have to start from the beginning. You can pick up where you left off. The tool will look in the replicate table and figure out the last work that was completed and then start again from there. The max load option causes the tool to observe how much load there is on the server. And it's rather flexible. You can specify it in a number of different ways. But by default, it looks for threads running, the show status counter, threads running, be greater than 25, and it will throttle itself if there are more than 25 concurrently running queries. That's too much for a lot of people, but it's not enough for a lot of other people. So this is something you might want to configure yourself. What happens is if there are more than this threshold number of queries running, or whatever other variable you decide to compare against, the tool will just wait until that load dies down. And sometimes you'll see that if a server is under pretty heavy load, you run a checksum query, and a few incoming queries will back up a little bit. And so immediately after the end of the checksum query, the tool will look at show status and determine what the server looks like immediately after completion of the query. And if the server's load has increased or there's been any sort of blocking or delay on the server during the running of the checksum query, you will notice it immediately after that checksum query completes. So that's why it looks for load immediately after completing the checksum query. So you might want to throttle that down. You might want to, for example, say, don't run any checksum queries until the load on the server is less than 5 threads running at any given time, or something like that. The documentation explains that in more detail. There's also quiet. By default, the tool is verbose. It'll print out one line for every table. And as you saw earlier, everything was 0 in that sample of the output that I showed you earlier. If you give it the quiet option one time, it will print out a row of output only for tables that have differences. So this is a great way to run this tool from a cron job or the like. And by the way, if it detects that there are any differences, it will exit with a non-zero exit status. So you can give it quiet option twice, and it will print out nothing. It won't even print out progress reports, which it does print out progress reports by default in a pretty nice way during all of the different types of waiting that it does. But if you give it quiet twice, it won't even print progress reports, and that makes it really nice for a cron job or some other kind of a job to detect whether the tool found anything wrong. So you can use this in an Agios check, for example, to send an alert if any data differences are detected on any of your replicas. And finally, the retries option is 2 by default. You can set that higher. This can make the tool more resilient. If it gets disconnected twice in a row, for example, then it'll say, okay, I'm out of retries, and it will exit. If it gets disconnected once, then it will reconnect and continue doing some more work, of course. And there are a variety of places where it will retry. It'll retry a NODB lock wait timeout and a whole bunch of other things. And if you think that your server is more likely to have a lot of error conditions that the tool needs to recognize and recover from and continue doing its work, you can increase the retries option. Replica detection is one of the things that is imperfect, and that's just a limitation of MySQL. This is going to be significantly improved in MySQL 5.6, by the way, where server UIDs are included in the server. But in MySQL 5.5, which is the current GA release of MySQL and earlier, we have to use some tricks to detect the replicas that are connected to the server, and that doesn't always work. There are a couple of different methods that the tool will use. It will look at show process list and try and detect where replicas are connecting from so that it can go and connect to them in turn. And it will recurse all the way down through your replication hierarchy, no matter how tall it is. But in a lot of cases, a replica will be connected to the master from an IP address that actually doesn't accept incoming connections, or you won't actually understand which port the server is listening on. So when you try and connect back to that IP address, there's no listening port there. So this is an imperfect process. And if it doesn't work right for you, or if it detects servers that you don't want it to, for example, some people don't want us to throttle the tool based on one replica or another that might run a really long-running operations or be under extremely heavy load because of, let's say, some data warehousing or something like that. Some people tell us, make the tool ignore that server because I don't care whether that server falls behind in replication. Only look at these other set of servers. So the perfectly flexible and foolproof way to do this is to create a little table and specify some DSNs. A DSN stands for data source name, and that's how pt-table-checksum knows how to connect to a MySQL server. So you can create a table full of connection instructions and point the tool at that. That disables the automatic detection, and that's your perfectly flexible, ideal way to connect to and monitor only the servers that you care about. So that's probably, I would say that is maybe 50% of people who need to actually specify some command line options to the tool need to specify exactly which replicas should be connected to and monitored. So I'd say this is one of the more common command line options that you might actually need. And you can read the documentation to learn exactly how that works. So that's it. The tool is actually, I'm extremely pleased with it. Daniel, our lead developer, did an amazing job with it. And as a result, there's not a whole lot to talk about, which is it's actually kind of nice. So I'll go through a few resources here in our remaining time, and then I'll answer any questions that you have. Which reminds me, I can't actually see my question panel, so let me just check and see whether I have any questions that Terry has tried to ask me.
Yeah, Bear, there's been no questions submitted yet, but if anyone would like to ask one, please submit it through the Q&A panel in your WebEx control panel.
Okay, great. Thanks, Terry. All right, I'll go ahead then. So let me just make a few comments on the state of Percona Toolkit. We've recently hired another dedicated developer, Brian Fraser, who's a Perl genius. He's actually participated in a Google Summer of Code project last year, fixing a whole bunch of Perl internals itself. And it's been great. He's been with us a little bit over a month now, and he's made a lot of really nice suggestions and really taken our Perl expertise one notch higher. Most of the tools are written in Perl, so that's highly relevant. A number of the other tools are actually written in Unix shell script. But it's nice to have a real Perl genius on board. I consider Daniel to be a genius as well, and I have quite a history with Perl myself, but when you hire somebody that knows that much about Perl internals, you learn a lot. So we now have 2 dedicated developers who are working on Percona Toolkit, and we're getting a lot done. We should have a release about once a month, and we should have a release coming up soon with 2 much improved tools in it. pt-stalk is a tool that I've given webinars on in the past. If you're interested in that, you can look at the recordings of those webinars. pt-stalk is a tool that lets you gather diagnostic information about problems that are happening that you can't observe, intermittent server failures. And I think the title of that webinar was Diagnosing Intermittent Server Failures or something like that. Well worth a look. The new pt-stalk is rewritten from the ground up, and in the future, Daniel and I have gathered data sets from, we've had some very large hosting companies contribute data sets from their production servers. So we have, I'd say, close to 10,000 servers worth of data sets that we're going to use to detect automatic fault detection algorithms. That should be coming out in a few months, but we haven't nailed down the exact algorithm yet, so it's a little premature to talk about that. In any case, the new pt-stalk is a very nice tool, and it has a lot of features that our consultants and customers were requesting a lot, and features that I know I missed myself a lot. And we've also got a pt-diskStats tool coming out. That's a tool that exists right now, but we've ported it from Bash into Perl. Perl turns out to be a better fit for that. This is a replacement for IOstat. It's a much better and much nicer replacement for looking at disk activity on Linux servers. And after that, we've got a raft of new tools and improvements to existing tools that are slated to come out. And as a final note here, if you have any problems with Percona Toolkit, if you don't understand how to configure them, how to use them, how to extend them, or if they don't do what you need and you need custom development, you can get that as part of our Percona support contracts, or indeed any contract with us, any development or consulting or support contract entitles you to get Daniel and Brian and myself working on those tools for you to make them do what you need. A few more resources. The documentations and downloads are at percona.com/software/Percona Toolkit, and there's a PDF manual that you can download there as well. That's the documentation manual from all of the tools included into one PDF bundle. We do also offer training courses, and those are in major cities worldwide. We're running one in Washington, D.C., I believe right now, this week. Is that right, Terry?
Yeah, that is correct. It is running this week.
And we have upcoming, what do we have upcoming? Dublin and Frankfurt, Germany, and a number of other places. Can't remember off the top of my head. But those are all listed at the URL that I've shown there. I mentioned High Performance MySQL 3rd edition coming out in a couple of months. That's a great resource, I think. And there's quite a bit of coverage of not just what the tools do, which is included in the tools documentation themselves, but how you actually use the tools to achieve particular purposes. And we've extended beyond command line tools onto some online tools as well. We're building a suite of online tools. Not everything is best at the command line. The first of our tools is available at tools.percona.com in that suite, and that's a configuration wizard to help you generate a my.cnf file for your MySQL server. So you can input some parameters, and it walks you through a 7-step process. And at the other end, you get a sane MySQL configuration file, which is a good base. And this originated in response to this common request that's been going around for many years, which is what's the best default configuration file for a server with this much hardware and this much memory and this kind of a workload and all of those kinds of things. And there's never been a good answer to that because it needs some intelligence. It needs some real smarts to go into that to develop a good default configuration file. So there's no one-size-fits-all MySQL configuration file, but with a little bit of magic behind this tool, we've been able to provide some pretty good, sane configuration files that are much, much better than the defaults that actually ship with the server. Those are one-size-fits-all, which means that they're really one-size-fits-none. And again, there's an online, you'll be required to register for an account, and that account will become your home page, your repository for all of the configurations and every other tool that we introduce in the future. You'll have all of that stuff in your profile, whatever you do with those tools. Espen, our Vice President of Global Services, is presenting in a couple of weeks on preventing MySQL downtime in production environments, and that's based on a lot of research we did into our customers' downtime causing incidents. So I think if you're interested in preventing or knowing why downtime happens, I think that's a very interesting webinar for everyone to join and attend. And of course, the ultimate is when thousands of, over 1,000 people, not multiple thousands, but over 1,000 people should come together for the MySQL Users Conference, which O'Reilly used to run every year, every April, in Santa Clara, California at the Santa Clara Hyatt Convention Center. And O'Reilly's not doing it this year, but we are. And you can go to www.percona.com/live to find out more about that. And next week, we're actually going to reveal the breakout session schedule of all of the technical sessions there. We have a few days packed with tutorials and schedules, and that's all going to be published, I believe it's Monday. We have not chosen those talks ourselves. We opened up a call for paper to the community, and we invited community members to participate in a committee that actually chose those talks. And those committee members are the most recognized names in the MySQL world. Those are some of the people who have been around MySQL for, some of them, more than a decade, and they've chosen a really amazing slate of talks. We had at least twice as many good technical proposals than we had space for. but this is really going to be an amazing conference. So I hope to see a lot of you there. And finally, I wanted to mention a lot of the replication problems that I've talked about today actually come from the asynchronous nature of MySQL replication. When you commit something on the master, you have no strong guarantees about whether replicas have fetched it and applied it. Now, in MySQL 5.5, there's something called semi-synchronous replication, but that really doesn't give you, again, an ironclad guarantee that all of the replicas have fetched and applied that statement. And it also doesn't prevent you from some of the other failure scenarios that I mentioned. So MySQL replication is architecturally limited. It's the fundamentals. It's not something that can be changed with patches or improvements in new releases. It's always going to be this way. And that's not necessarily a bad thing. I mean, remember, MySQL replication is what a lot of the internet is built on, and it's what made MySQL the database that became the world's most popular open source database. But there is a new replication technology that has come out, which is called Galera, and we have bundled that together with Percona Server, and the result is called Percona XtraDB Cluster. That is in our first release right now. It's not a general available release. It's an alpha quality, and we're looking for people to test that and give us feedback. It is available at the URL I've listed there, and this is all open source free software. I have a few minutes to describe this, so let me just mention that this is synchronous cluster-wide replication. You commit a transaction, and it is shipped to all of the other servers in the cluster, and it is certified there that it will be applied without any conflicts, so you won't get any breakage. And that also means that you can write to all of the nodes in the cluster. All of the nodes are equivalent. They're peers of each other. There isn't a master-slave relationship between these nodes. They're all equal. They all have the full data set at all times. And so you can write to any of them, and you won't have any conflicting updates or anything like that. And your changes will be synchronously replicated to all of the other servers in the cluster. This means that you can also read from any of them. You don't have to, the cluster is immune to replication lag, so you don't have a replica that falls an hour behind, for example. There are a lot of other nice properties. It creates high availability. All of your servers have all of the data, and they are guaranteed to have all of that data at every time. So this brings a couple of nice properties. The first is that if a server fails for any reason, it's no problem. You can just connect to the other servers and continue your work. So instantaneous failover, no sort of master-slave promotion kind of scenarios, none of the awkwardness that comes with trying to promote a server to be the new master in case the master fails, because all of the servers are masters at all times. And it also improves performance a lot because the cluster as a whole is durable. This means that you can relax durability on any particular node. And this is a very common technique. Writing to remote servers' memory is faster than writing to your own disk. So basically, you rely on the synchronous replication to guarantee that your data is durable. That means that you can turn off durability or relax durability on the node itself and get much better performance. And this is especially important in EC2 or other cloud environments where the disk is not only high latency and low bandwidth, but it's extremely unpredictable. So we have lots and lots of problems with servers running in Amazon in these unpredictable environments, and you can basically tell the server, look, unpredictability doesn't matter anymore. You're replicating across the network, not to disk. And you get much better performance. So it can help you to scale writes to some extent as well. So, yep.
Are you ready for some questions?
I certainly am.
All right, excellent. We have a number here. To begin, do you need a dedicated MySQL server that can connect from the master?
No, you don't. You can run pt-table-checksum from anywhere. So that's a great question. You don't even have to run it on the master. You run it against the master, but the tool itself can actually execute on any server and just connect across the network to the master and do the work there. There's extremely little data transferred between the MySQL server and pt-table-checksum. So it is not it's not a problem to run it across a slow, low latency, a high latency network link or something like that. And it also does not add much load on the server that it actually executes on. So you can perfectly well run it on the master MySQL server itself, and it won't intrude. It won't cause any interference there.
Okay. After pt-table-checksum tells me there are differences, how do I see the actual differences?
So after pt-table-checksum says that there are differences in the table, there's another mode that you can run it with. There's a command line option that will get it to print out the chunks that differ. You can also go to your replica and query that table itself, and you can find the chunks of data that differ. And there's the parameters to the index that it used to paginate through the table to create the chunk boundary. So you can actually create a where clause. And pt-table-checksum is integrated with another tool called pt-table-sync, which understands the same table format. So if there are differences, you can also just run pt-table-sync against the server, and it will detect those chunks, and then it will go and dig in at a row level instead of at the chunk of rows level. And you can use the print option with pt-table-sync to get it to print out which rows actually differed between the master and the slave. You can also get it to synchronize those records in a safe way. For some reason, I can't see the question panel myself. I'm not quite sure why. Let me see if I can bring that to the front or something.
The next question is, does the Percona Toolkit work on Windows Server?
Yes, it does. There are a couple of tools in Percona Toolkit that are written in Unix shell. Those will not run. Those are Unix specific. But the majority of the tools are written in Perl, and all you need to do is install Perl. There are a couple of good distributions of Perl that work very well on Windows. One of them is Active State Perl, and there's another one called Strawberry Perl, which seems to be more popular among Windows users.
And a related question is, do we need to install the latest version of Perl?
No, the tools are designed to run with old versions of Perl. So that's one of those other things that as consultants, we are kind of subjected to very old versions of software and libraries, so we work around all of that.
Very good. Are both NODB and MySQL tables supported in pt-table-checksum?
Yes, every storage engine is supported. It'll work regardless of storage engine.
By default, the chunk time is 0.5 seconds. Does that mean that a whole MySQL table could lock up to 0.5 seconds for each chunk?
Yes, that's true. If you're running this against a MyISAM table, then you will see locking because of the way that MyISAM works, table level locking. So in case you're running it against MyISAM, you might want to run it with a shorter checksum time. And that actually gives me an idea of an improvement that we can roll into a future version of the tool. We could actually run it with a low priority so that it won't block any other select statements. Let me make a note of that.
Okay, very good. Does the checksum tool work in a master-master replication environment?
Yes, it works in every replication environment. What you want to do is run it against your active master. A lot of replication problems are caused by having one server that's the canonical active master against which all write queries should be directed. And other servers are eligible for running reads against, but you should not modify any data on them. You want to run this tool against your active master where writes are allowed and safe. You don't want to run it against the passive server in your master-master pair.
Okay, very good. In the situation where there are checksum mismatches, the question is, are there best practices for resolving mismatches or correcting drift?
So the best practice that I would suggest is to learn pt-table-sync. This is one of those tools that's extremely powerful, and it does the right thing in most cases. However, it will give you enough rope to hang yourself. I mean, it also does a lot of safeguards, but if you tell it to go and change data in a way that might cause further problems, it's actually possible to do that. So the the tool is designed to do a lot of very complicated and sophisticated types of things. So it's not something, my point here is not to scare anybody away from using it, but to make sure that people understand that this is something you really want to read the documentation on and experiment on some test servers, for example, before you run it in production. And I should have mentioned pt-table-sync in this presentation. I'll mention that in future versions of it.
Okay. Another question, will pt-stock be rewritten in Perl, or will it continue to be a Unix shell?
pt-stock will continue to be in Unix shell. There are a number of tools that we have had some experience trying to write in Perl and discovered that it was not the right technology. Perl is not that great and can suffer from platform-specific bugs in things like executing system commands, for example, whereas Unix shell is absolutely built for that from the ground up. So that one is a Unix shell tool and will remain a Unix shell tool.
Okay. What is the difference between table checksum and heartbit, and which one should you use and when?
Table checksum detects whether the data has become different on the slaves. PT heartbeat detects whether the replication is actually delayed and falling behind.
Okay, very good. We have a question. What is the difference between MATKit and Percona Toolkit?
So MATKit was what I worked on for many years. There was just some conflict, sort of a open source versus community versus company controlled kind of a conflict in me spending a lot of time and effort, and in Percona funding salaried employees to work on the open source toolkit. We felt that it was a much better fit to discontinue development on MATKit, since we were the only ones who were developing it anyway, and bring it in-house and call it Percona Toolkit. So MATKit plus Aspersa equals Percona Toolkit. And in fact, it has worked out as we had hoped, that it's just a much better fit for actually naming it Percona Toolkit and acknowledging that it's under Percona's control, because we're the ones who are funding the development of it.
Okay, we have a question. Does pt-table-sync do two-way data sync?
pt-table-sync actually can do two-way data sync. Yeah, that's one of the advanced features that you need to read the documentation quite carefully to understand how to use correctly, especially if you're in a complicated environment such as master-master, and you're trying to, let's say, resolve some conflicts that have been caused by an error, and you've got some data on each server that you want to keep, but neither server has all of the data you want to keep. That's the kind of use case that we developed that complicated functionality for.
Okay, let's see, two more quick questions here, and it looks like we're out of time. One is, can pt-table-checksum be run in a sharded environment with multi-master?
Yes, it can. It works perfectly.
Okay, and final question here to wrap up. Is the config wizard provides valid for Linux and Windows installs of MySQL?
Yes, the configuration wizard understands Windows, Linux, and a number of other operating systems. So it works fine there.
Fantastic. We're at the end of our time. Baron, anything else you wanted to say to wrap this up?
I just flipped to my last slide here. That's got my contact information and my Twitter handle. And I'm delighted to have email conversations with folks about this. There are also mailing lists, which I probably should have mentioned. That's a good community resource, and our forums, forums.percona.com, where you can get answers to questions. But if you want to contact me personally, I welcome that.
Very good. Thank you, everyone. Thanks for attending today. A recording of this webinar has been made, and we will distribute the link to the recording via email to everyone who registered in the next day or two. So by the end of the week, you should have a link to the recording for the webinar. Thanks for attending.
And we'll post this to the slides also.
And the slides will be posted also. As Baron mentioned also, Espen will be speaking about preventing downtime in production MySQL servers next Wednesday, and we invite you to attend that presentation as well. Thank you for attending today. Have a good day.